enough, it'll be caught. Their team is pretty good in terms of constantly scanning the content that's on that site. Blogspot, multiple files every single day. It's still one of the top 10 sites that you'll find multiple malicious exploits hosted on Blogspot. They're making use of all the free accounts, free access, the trust factors within Web 2.0 to store content, more exposure to users. So they're doing a lot with Web 2.0, but they're not really changing anything in terms of exploit delivery. There's no change there. So let's talk about Web 2.0 exploit delivery. So this is really the core of my talk, is what is the next generation of content delivery. It's one technique called script fragmentation. And that's active content. You can do it with JavaScript. You can do it with VB script. And it's fragmentation, little chunks of data. So script fragmentation, in its most simplistic form, to explain it, is malicious AJAX. Asynchronous JavaScript in XML. Doesn't have to be XML, by the way. That's just one choice of a data form. But it's malicious asynchronous communication. So fragmentation, it rings a bell, sure. TCP fragmentation, still a big problem on IDSs, IPSs. But what's the big difference? Well, TCP has an RFC that, if followed correctly at least, given fragmented packets, you can reassemble. There is some type of standard. When we're talking about script fragmentation, we're talking about the application layer. This is a completely custom layer. It's per application. You have custom applications. There's never really going to be ever a standard to what's happening on the application layer. TCP fragments, there is a standard. Script fragmentation, I can every single day create a polymorphic application to how my script and my web server are going to communicate. So application fragmentation. I can certainly use asynchronous communication. That's my choice. I'm going to be building custom protocols on top of the application layer. There's absolutely no standard because it's my application. Web apps are huge in terms of communications back to the client. And imagine the complexity and the power that you have from the perspective of the browser. The browsers are one of the few types of applications that will visit a completely anonymous site, download JavaScript, download VB script, which gets fed into memory, and execute it. You're just executing unknown code. And sure, there's a lot of things that JavaScript can't do. It's sandboxed, but there's a lot of things it can do. It's pretty powerful. I mean, we're going in memory and we can do things. I can, for example, embed, if I'm talking about some Stego techniques, I can embed content that I want inside of an image, and using kind of canvas within JavaScript, I can go and read bytes from that image. So I've somehow, another evasion technique, brought content together, read from various different files to do what I please with. JavaScript is a very powerful language, and it's going to become even more and more powerful. But the fact of downloading content and being able to just execute it is quite amazing, and that's why we're at where we're at with in terms of the web. But there's a lot of malicious things we can do. So let's see what we can do. And for that, what I'm going to do is, it's a quick lesson, but I want to involve everybody in terms of understanding this. I'm just going to go to some real quick basic JavaScript. So HTML, I'm hopeful that everybody already understands the basics. We're going to talk about real quickly what the browser document object model is, the DOM. We're just going to go over some basics of what you can do with JavaScript. I'm not going to really mention JSON. I'm going to show you what the XML HTTP request object is, something you use for remote request. And we're just going to touch on the X-domain request object, the cross-domain request object. So when you go and visit a website, let's just say that it comes down with the first of the top code, HTML body, div body, HTML. You have the notion of what's the HTML. The HTML is the top. What's the DOM? Well, that's the memory representation of that initial HTML. So at the basic start, they look identical. Now, had that same file come with some JavaScript on top. And let's look at that slide again. It had a div tag with ID equals target. Had that same file come down with JavaScript, I could grab that node that equaled target. I could create an element, another node, that was called script, and I could embed some content. Nothing malicious in this example. I'm just going to embed an alert box. And then I embed it. As soon as I embed it, it actually gets executed. So obviously you can see that what's happening here is that I can dynamically change around my, not HTML because that's static, my document object model, which is the constant memory representation of what's happening in that HTML. So the new DOM looks like this. That alert box got executed, but the HTML document on disk, when it goes down into your cached file, looks absolutely the same. So basic HTML document, HTML body. Again, say there was some JavaScript on the top there, and it just created var text equals alert text test. And I can then call the function eval text. Eval, what that does is it takes its arguments and just executes it like it was a script, like it was just JavaScript or VB, well, like it was JavaScript. So it'll just execute that. It really played the same purpose. The difference here is that the DOM stayed exactly the same. I didn't create a node and embed anything else. And of course, the power of scripting, being JavaScript is Turing complete. You can do, infinity of multiple combinations in terms of how you're going to create that text. That same thing, alert test. I could have just concatenated the string together and then evaled it. But obviously, this is the constant problem with signature analysis, right? I cut up my string as many ways as I want to and in many different ways, and I see how the signature analysis engine does. So let's touch on what the XML HTTP request object is. So this is something that was at first an ActiveX control within IE, then actually became more native. This is an object you can use inside of JavaScript that says, all right, my code has come down. I'm going to create this object called XML HTTP request. Go get the content from the CGI page, and then I can do something with it. But in the background, basically, I can go and fetch content. I can do post and I can do get. Very useful and used almost everywhere in terms of Web 2.0 applications. Even more interesting, actually, though, is something new that's available in IE8 and later versions of Firefox. This is the cross-domain request object. Now, same origin policy said that really we could only go and fetch the content from the same server that our content came from. Well, this is totally different. This is the assumption that I can actually go and contact any domain. And the one detail here is that that domain in its header has to say it's okay that I'm actually going and requesting content from there. But this is extremely powerful. Imagine I bring down content, and then that content is going to go request from any server I want that other content. Obviously, in a mashup, like for good applications, this is what you want. You want to be talking to other cool applications all over the web. That's pretty much all we're going to go over for JavaScript, and that's what we're going to need to talk about script fragmentation. So dynamic retrieval of data. That's what we were talking about with XML HTTP request. So what can I do? Little simplistic example. I do a get with my XML HTTP request, and I have a query string. It just says q equals 2 plus 2, and I check what the response is. 3 lines of code, 4 lines of code. 4 comes back. Simple. But I can actually do dynamic retrieval of data, dynamic question and answers. So what can we do with this in terms of maliciousness? And that's the perspective we're always trying to have. Script fragmentation attack in its basic form. We're going to store malicious content on the server. Now, when we store that malicious content on the server, we're not going to expose it. It's not a web page that you can go visit. It's hidden in a directory that your application can access, but it's not exposed otherwise. The server is going to have a web page. That web page is only going to have a decoder routine in there. So when I'm a user and I go visit a web page, there's basically going to be an algorithm that comes down, and that decoder is going to be use of that XML HTTP request. Once it comes down to the client,